Hello everyone. In this video, I am going to cover the concept of pre-pruning and post-pruning in decision tree. What is pre-pruning? Pre-pruning is stopping the decision tree from growing. If you read the definition, pre-pruning stops decision tree from growing too deep while it is being built. So basically, pre-pruning and post-pruning are control, used to control I would say used to handle. That would be better. Used to handle overfitting and underfitting. Overfitting and underfitting. In the pre-pruning, it will stops the decision tree from growing. While in post-pruning, it will first build the tree. Then it will cut the branches to make the tree small. So this is the difference between pre-pruning and post-pruning. I will show you like 4 methods of pre-pruning. When we are defining our decision tree model, suppose consider decision tree classifier. I have defined here max depth is equal to 3. Max depth is equal to 3. That means our model should build a tree starting from the root node. Starting from the root node should make a split. Okay. This is depth 1, first split. And then it should make another split. It can make another split. This will be depth of the tree now is equal to 2. If the tree again further makes one more split, then the depth of the tree will be 3. And now my model, my machine wants to make the further split. It's not possible. It will stop it from making the further split. If your model is overfitting or underfitting, you can define this feature to stop further splitting of data. And this consider this as your leaf nodes. Consider these as your leaf nodes to make the prediction. Max depth is equal to 3 will perform this operation. This is an hyperparameter here. Hyperparameter. Okay. The second hyperparameter is minimum samples equal to 5. What does this means? Minimum sample equal to 5. If node contains less than 5 samples, stop splitting. Stop splitting. If I show in a tree, consider this is my tree. It has 20 data points, 20 samples. Okay. It has splitted into 10 and 10. Equal split. I got the equal split. Further, this node has split the data into 5 and 6. Sorry, 5, 6 and 4. And this has split the data into 7 and 3. So we have these nodes now. If you see here, our condition is node if node has less than 5 samples, stop splitting. Then the node, this node and this node. Here the samples are less than 5. So these nodes cannot be split further. We cannot split these nodes further. but these nodes we can split it further. This hyperparameter minimum samples is equal to 5 will stop the splitting of these nodes. This way we can pre-prune our decision tree by defining the hyperparameter minimum samples is equal to 5. The next hyperparameter is minimum samples leaf is equal to 3. Minimum samples leaf is equal to 3. Let's draw a tree. We have some n data points and we have built the tree. Okay. Now this data point has 10 samples. Okay. This data point has 10 sample points and it will split the data. This left child will have 6 data points and right child will have 4 data points. Here again this node will split the data. This node has 10 sample records. It splits the data. Left child will have 2 samples. Right child will have 8 samples. What is our condition here? Leaf, n samples in leaf should be equal to 30. N samples leaf, minimum samples in leaf should be 3. Sorry, not 30, should be 3. So minimum it should be 3. That means samples in leaf should be greater than or equal to 3. Then that split will be accepted. If leaf has more than or equal to 3 samples, accepted, or else reject the split. Reject split. What has happened in this case here? See, in this split, there are 2 leaf nodes. 6, this one, left child and right child. These are 2 leaf nodes. Here the leaf node, it is greater than or equal to 3. 6 is greater than or equal to 3. And 4 is also greater than or equal to 3. Then this split is accepted. And in case of this split, our left child has less samples. 2 is less than or equal to 3. 2 is less than 3. It is not greater than or equal to 3. This leaf node samples are less than 3. This is rejected. This split will get rejected. The entire split will be rejected. The machine says you cannot make this split because your leaf is getting less than 3 samples. Why? Because I have defined the parameter minimum samples in a leaf is equal to 3. So this is one more hyperparameter which you can use in pre-pruning. Before splitting itself, I am defining what minimum sample leaves I want and what minimum samples in the node I want, what minimum samples in the leaf I want, what the depth of tree I want. I'm defining it. before constructing the tree, that is pre-pruning. And see this parameter, the next parameter, fourth parameter, minimum impurity decrease is equal to 0.02. When building the tree, we are calculating the Gini impurity, right? For every split, we will find the Gini impurity and then select the least impurity to split the data. As we make the splits, as we split the data, our Gini impurity will start decreasing. For every split, the Gini impurity is decreased. Suppose initial the Gini impurity was 0.45, and at this split, the second split, the Gini impurity is 0.41, and at this split the Gini impurity is 0.39, but at this split the Gini impurity is 0.38. When I make the split from this node again, the Gini impurity is 0.38. Sorry, when I made the split, the Gini impurity at this level is 0.38. So if we see the difference, what is the decrease in the impurity here? 0.45 to 0.41, it is 0.04. Then this will be accepted. Between this, okay, and what is the decrease of Gini impurity here? 0.41 minus 0.39, that is 0.02. So it is satisfying my hyperparameter. So this split will be accepted. But what about the Gini impurity here? What is the decrease here? 0.01. Here it is not satisfying the condition minimum decrease in impurity is 0.02 because it is just 0.01. It is less than 0.02. So this split will not be accepted. It will prune it out and it will cut this out, remove it, will reject this split. This is pre-pruning, why you can define the impurity decrease. So these are the 4 methods I have explained you. There are many more methods. I have explained you 4 methods. Max depth, minimum samples in a node, minimum samples in a leaf, and minimum impurity decrease. These are the hyperparameters you can use for pre-pruning in decision tree to overcome overfitting of data or underfitting. Okay. Next is post-pruning. First we will grow the full tree, and then first we will grows the full tree. Will grow the full tree, and then removes the branches. Which branches? Which does not improve your performance, which does not improve the performance of your model. Model performance is not improving, then you can cut out, then you can remove those branches from the tree. Example, see at this split your accuracy is 0.89. You make the split further, you made the splits, and what is the accuracy? 0.39. 892. What is the increase here? 0.002. So this is unnecessary, right? This will make the overfitting of data. This is unnecessary. This will cause the overfitting of data. Or you see here, accuracy is decreasing after 0.89 in this case, or your accuracy has decreased here. Your accuracy has decreased by 0.04. In such cases, if the split is either not, if there is no much increase in the accuracy, it is just overfitting the data, or it is decreasing the accuracy, it is underfitting the data. In such cases, you can remove those split by post-pruning. For this post-pruning, the parameter, the hyperparameter is CCP underscore alpha is equal to 0.01. This is the value which you can specify. This is the hyperparameter CC underscore alpha. If it is small, consider 0.001. Then there is less pruning. CCP alpha value is less, there will be less pruning. That means large tree. And if value is larger, is more pruning, smaller tree. So CCP alpha value is inversely proportional to size of tree. CCP alpha value is inversely proportional to size of tree. Okay, so this is the post pruning hyperparameter. This completes the pre pruning and post pruning in decision tree. Thank you.